Hello students, I'm going to review structural elucidation exercise 4. Okay, so I'm going to work on the first question first. Okay, so you have P, which is a sex attractants for the barking boring beetle. You were told that it has the molecular formula C10H16O. Okay, so for this particular question, you notice that it is much shorter than the one you saw earlier on for elucidation exercise 3. Yeah, so I should be able to review it under 10 minutes. Okay, so for the structural formula C10H16O, I'm going to calculate the degree of unsaturation. So that will give me 3 degree of unsaturation. Okay, so that's 2n plus 2, 22 minus 16 divided by 3. So I'm going to get 3 degree of unsaturation. You were told that it underwent gentle oxidation with potassium dichromate to give you compound Q. You'll notice that the difference between the formula for P and Q is a reduction in 2H. The number of oxygen did not change. So from here, you can safely conclude that P is a secondary alcohol. Okay, and Q is a ketone. Okay, why is it that we can conclude in this particular manner? Well, I mean, the first thing you look at it is that, okay, first of all, what we want to focus on is P contains 3 degree of unsaturation, so that means that it can have a combination of 3 double bonds, 2 double bond, 1 ring, etc., etc. And then with an oxygen, well, I mean, it could either be ketones or aldehydes. And then over here, you were told that upon oxidation, you are getting Q, and then after that, you were told that Q gives orange PPT with 2,4-dinitrophenolhydrazine but does not give a brick red precipitate with Fehling's reagent. So from here you can conclude that Q is a ketone. If Q were to be a ketone, then therefore P has to be a secondary alcohol. Yeah, usually if P is a primary alcohol, right, oxidation, if it's not controlled, right, will usually give you a carboxylic acid, and you will notice that the number of oxygen will increase by 1. Yeah, if P is a tertiary alcohol, it will not be oxidized. Yeah, so from the molecular formula itself, you can it will be able to give you some clue on what P potentially is. And then you were told that treatment of Q with co-dilute acidified potassium permanganate gives R. Okay, this is a very important clue because you notice that the number of hydrogen and oxygen increases by 6. Yeah, so that means that R contains 3 sets of diol. Yeah, so again, if you recall what we mentioned earlier on in structural elucidation exercise 3, we mentioned that the co-dilute acidified KMnO4 condition sort of give us another clue to whether a CC double bond is indeed present. Yeah, so in this case, we can sort of conclude that yes, the 3 degree of unsaturation present in P is solely due to the 3 CC double bond. Okay, so from here, we can say that Q contains 3 CC double bond, and of course, if Q contains 3 CC double bond, that goes the same for P. And then with hot acidified KMnO4, Q gives ST and carbon dioxide in a 1:1:2 ratio. Yeah, so this is not the first time you are saying this. 1:1:2 ratio. So this sort of tells you that Q contains a terminal alkene. Okay, so not just 1 but 2 terminal CC double bond. Well, some of you might argue that, okay, it need not be a terminal CC double bond, right? It could be a consecutive C double bond C and C double bond C, because in the middle, if you get ethane dioic acid, you will still get 2 CO2. Okay, not a problem with that. That is a plausible conclusion you can come up with, but later on, as we work through the problem, you know that that is not the case. Okay, you were told the structural formulae not structural formula, the molecular formula for S, okay, is C3H6O. This particular fragment, you have seen it many times. You'll notice that in most structural elucidation question, we will give you this fragment, which essentially is proper known because it gives you a positive iodoform test. And under strong oxidation condition, this cannot be an aldehyde. Okay, so from here you can easily conclude that S is proper known. Okay, you can even number the carbon if you want. So I'm just going to number it as 1, 2, and 3. Okay, and fragment T, in this particular question, they made it much easier for you. So they tell you how T can be synthesized. So you need to know your chemistry very well. Okay, so let us go through the synthesis. So the synthesis begin with a dialdehyde group. Okay, so we have a dialdehyde over here. Okay, undergo cold condition, so HCN in trace KCN. Okay, in this case NaCN cold condition, it gives us U. Okay, so in this case, I'm going to predict that it's likely to be a nucleophilic addition reaction. Okay, so this is a nucleophilic addition reaction. I'm going to get a 2-alcohol group. Okay, and then after that, when I heat it with potassium dichromate acidified, okay, this is likely to be an oxidizing condition. Okay, so I'm going to get oxidizing condition, double bond O, and then CN. Okay, and then after that, undergo in the presence of sulfuric acid, the cyanide group will undergo hydrolysis. So this will be acidic hydrolysis. Okay, and I'm going to just draw out the final products. Okay, you get a lot of double bond O's here, double bond O, and then double bond O and OH. Okay, so this is T. Let us just take a look at the structural formula and molecular formula to see if they matches. You have 5 carbon, okay, 2, 4, 5, and then 6 oxygen and 4 H's. So that works perfectly fine. Okay. Now, the next thing we are going to do is we'll try to combine the unknowns together in order for us to work out a potential structure for Q. Okay, so with that, I'm just going to number the unknowns here. Okay, so sorry, I'm going to number the carbon in T. Okay, so earlier on, I've numbered S to be 1, 2, 3, and then I'll just continue 4, 5, 6, 7, and 8. Okay, so 8 carbons in total. So we have accounted for 8 of the carbon, S and T, and then 2 of the CO2 will be terminal alkene. Yeah, so from the structure of T, you know that this particular structural feature is not likely to be present. Yeah, so I hope you can see it from the structure. Okay, if not, you can try to work it out and convince yourself that. Okay, so with that, we'll do the same thing as what we did for elucidation exercise 3. Okay, so we just mix and match. So we have C2 and maybe C4. Okay, so if we have C2 and C4, this is what we're going to get like this. And then maybe the ketone is here. Okay, and then I'm going to get a double bond here and a double bond here. Okay, so if I'm going to number the carbon, that will be 1, 2, 3, and then 4, 5, 6, 7, 8, and then 9 and 10. Okay, so this is one potential structure for Q. So I'll just call it Q1. Okay, yeah, so if this is Q1, then the corresponding structure for P, because Q is obtained from P via oxidation. Yeah, so if this is a potential structure for Q, and then therefore P will look like this with a double bond O and a secondary alcohol. Okay, and 2 terminal alkenes. So that will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that will be P1. Okay, and then what could another structure of Q be? Okay, so I can just swap them around. Okay, so again, I can have C2, C4, not a problem. Okay, then I'm just going to change the position of the double bond O. Okay, so to carbon number 7. Okay, so this could be a potential structure. Okay, yeah, then so what's going to happen is that, yeah, if this is Q2, then my P2 will take this particular form. Okay, double bond, and then OH, and then like this. Okay, Then could there be another possibilities? Can I swap? Can I put C2 with C9? If I put C2 with C9 and C5 get the double bond O, essentially that will be similar to Q2. Okay, so again, these are the two simplest possibilities which I can come out with, because at the end of the day, you need to maintain the fact that the ketone group has to be right in the middle, and that is the group which give rise to the secondary alcohol in the structure of P. Okay, so with that will be the end of question 1's review. And then moving on to question 2 is a really long question. So it's given to you to challenge your mind, and a clue is given right at the end of it. So this is a hint given to you. I think I've mentioned to it in the tutorial last year under oxidative cleavage for CC double bond. If you do not recall it, yeah, this is something which I have explained to you, the origin of oxidative cleavage. Yeah, so normally what we are comfortable with is strong oxidation like this, and then of course under cold dilute KMnO4, this is the diol formation which we get. But little did we know that the strong oxidation originate from the formation of a diol, and then slowly an oxidation of the said alcohol, followed by a cleavage between the two activated, or rather the activated CC single bond. In this case, it's over here. Yeah, but this knowledge is not required for your H2. Yeah, so if it's ever required, it will be given to you as a hint somewhere in the questions. Yeah, so please spend a bit of time going through this if you can spare the time. If not, you can just keep it for your revision in June, or even after towards your prelim, or even after your prelim. Or if you feel that elucidation is not something which you really want to delve too much on, it is perfectly fine as well, because for A-levels, we're not going to expect the elucidation question to be of this particular difficulty. Yeah, so this particular elucidation question is largely for you to make you feel satisfied to solve a very difficult problem. Okay, so yep, I will probably come up with a video to review this particular elucidation question in the future, but for now, just focus on your revision for the organic chemistry. Most importantly, just to ensure that you get all your contents up to date and you are able to link up all the concepts.